So awesome that you're all here. This is the workshop about gesture recognition and storytelling in Snap with artificial intelligence. And I wanted to start by showing a small example on what we're achieving or what we're trying to achieve here. Wait, let me sort my Zoom stuff first. Okay, so this is the project that we are going to build later. And the aim of this project is that we want to spark excitement for programming and for artificial intelligence, and that we want to go with you to the new frontiers of programming education by programming a gesture recognition in Snap, and then use the images that we recognized for animating our own stories. Whenever you have any question, feel free to ask it right away. I guess we can all unmute ourselves and ask stuff. You can also use the chat. Yeah, is that all right with you? I guess so. Also, I think Zoom has these raise hand features and stuff. I guess all of you know how to use them. So what we want to do in this workshop now is we will start creating a drawing program that can draw single stroke gestures. And then we will try to animate those gestures or sketches. And then we will try to record their paths in lists. And then we will try to recognize those paths and use the recognized sketch for the animation that we programmed before again. So let's start by all opening Snap. So in case someone of you hasn't used Snap before, this is where you can find it. It runs in any modern web browser. Just open it. Usually the motion category is open first. So the blue one. And for our drawing program, we want the sprite to always follow our mouse position. So or let's do the starting of this first. So we want the program to start whenever we click on the stage. So let's just in the stage program a little script that broadcasts a message whenever the stage is clicked. So let's do that first. We go to the control category and select the when I am clicked block. And whenever we're clicked, we want to broadcast something to all the other sprites in the project. And the thing we want to broadcast is, let's call the message sketch or something like that. So whenever I click on the stage, I'm now broadcasting this message. And then let's go back to the other sprite and let's call it draw, or maybe pencil. Let's call it pencil. And our pencil sprite is supposed to react whenever it receives that message. So to trigger the script here, let's grab a when I receive block. And the message that we're looking for is the sketching message from the stage. And then if we get that message, as I said, we always want to follow the mouse pointer. And we want to do that until, wait, do we need when I'm clicked? No, it's when I'm pressed, right, Jens?
Yes, that's right.
Sorry. Okay, let's go back to the stage sprite. The difference is the clicking event means that you click on the mouse and then release it again. So the mouse is not down anymore when the clicking event is done. What we want is we want to press the mouse and then keep the mouse down until we finished our sketch, and then we want to release the mouse. So we need to select another event here, which is the mouse pressed or the stage pressed event instead of the stage clicked event. Sorry for that. So let's go back to the pencil sprite.
I think it's actually a good teaching moment, Jadga. So we have a more fine-grained user interaction control. Click really is the full gesture. You press the mouse down on something and you release it, and then the event gets heard. Control, which is when the mouse is pressed or when it enters the sprite or something like that. That's why we have this drop down with more choices.
Yeah, feel free to also explore that at some point. For other things, mouse entered and mouse departed is also pretty cool. So feel free to use that in other projects. Okay, so what we want to do whenever we receive that sketching message is we want to follow our mouse pointer with the sprite. So for that, we have a block in the motion category, which is called go to. And this also has different input options in the drop-down menu. And the one that we want to use is go to mouse pointer, which means that the sprite goes wherever the mouse is. So if I click it now, it will just leave the stage and go there. We can also see that its X positions should now be something really negative, and it is minus 502. So I moved the sprite somewhere over here. And if we do that forever, for example, I can drag the sprite around with my mouse pointer. Okay. Let's move it back to the center of the stage. So we now want to do that until we released the mouse again. So we stopped clicking the stage. So let's use, instead of the forever block I just dragged out, let's use a repeat until block. And the condition that we want to use is we want to repeat this until the mouse is not clicked anymore. So for that, you can grab the not operator from the operators category and the mouse down predicate from the sensing category. So whenever the mouse is down now, this will report false, true, whatever. Not mouse down. When the mouse is down, it will report false. Okay, and this is what, false.
Well, of course, with the not,
yeah,
it'll.
With the not, yeah. So this script will keep running, and whenever I release the mouse, it will, or stop clicking it, it will report false then, and will stop the script. So let's try that. I click somewhere, and I can now drag my mouse around while I'm clicking it, and it will stop following the mouse whenever I stop clicking my touchpad. Okay, so this is the basic script, but we're missing the drawing part. So to add that, we can.
Wait, let me, Gavin. Somebody with fast computers might also have a problem that they accidentally pick up the mouse. So, right. So when we draw something, or did you want to say that? I'm sorry.
You're That's grinning. Okay.
Okay, I'm sorry. I'm going to shut up. I'm sorry.
No, it's okay. So let's put the pen down and up first, and then I'll tell you what Jens was trying to say. If you put the pen down, your sprite will draw whatever it's moving on the stage. So let me click that once. Now the pen is down. So this predicate is true. So when I move around the stage, it will now draw whatever I move. And if I put the pen up again, it will stop drawing when I move around the stage. So we need those two blocks, the pen down and the pen up block. And we want to put the pen down whenever we click the mouse and have the mouse down. And after we're done, we want to put the pen up again. So let's try that, whether it works. So I can now draw a heart, for example. What Jens was trying to say is whenever you click on your sprite, you can't draw anymore because you pick the sprite up from the stage. So your drawing program right now only works when you're clicking somewhere not on the sprite. To avoid that, you can just hide your sprite, but I would do that after you've taken care that your program actually runs. So this is why I wanted to do it first and see that it works. And then when you're sure that it works, you can just hide your sprite by using the hide block from the looks category and clicking on hide once. And now your program should work. One more thing that might be a good idea is actually cleaning the stage after or before you start a new sketch, so we don't have to start with this overly crowded stage. So let's add a clear block right at the beginning after the when I receive sketch block. And now we're ready to draw our single stroke sketches or single stroke gestures with our drawing program. Okay, let's try some. All of you maybe come up with some things that you can draw in a single stroke. Some letters, for example, work pretty well. So an S works well, or I can draw a Z, or I could draw a tulip, or I could draw a boat, as I've just did, or hard works pretty great. So just try your program with some different gestures. And then we go back to the animation part. What you can also do, by the way, is increase the pen size a little bit, for example. So we could set the pen size to something a little bigger so we can see it better. And that's not important for now, but the project that I've just shown you as an example at the beginning had a black background and white sketch, and somehow things look better when they're drawn on black with white. I don't know why this is, but if you want a more fancy project, feel free to also change the color of the stage. You can do that from the backgrounds tab in the stage sprite. And then you can also change the pen color of your sprite to something brighter, white-ish. So you can see stuff again then. Okay, let's give you 1 minute to finish that and try your things. And Hidaya, let's try to find out why your sprite doesn't move. So this is the script that you're supposed to have on the stage. This is the when I'm clicked block, and I selected pressed. So the script starts, or the script is triggered whenever I press the mouse, but not release it. And then the second thing is you need a second script that receives that message and reacts to it. And then whenever you receive that message in the sprite, you want to go to the mouse pointer, and you want to do that until you release the mouse again. So until your mouse is not down anymore. The last thing that might be an issue is also that you need to hide the sprite, so you don't accidentally click on it and drag the sprite around instead of drawing something. So try these 3 things, and if they don't work, maybe just write in the chat again and we can try to fix this. Okie dokie. So as I said, this is a project about storytelling and animating sketches that we recognized and drawn or have drawn. And we now want to, oh, I did that in an untitled script. We now want to give you some blocks where you can do that. And we should have given you a library. That was not very clever.
Wait, can I share a file here in the chat? I think
I don't know. Try that maybe.
Let me. Oh gosh, I'm struggling. Oh no, I think it should work. Let me see. Here is a file that is that you should just be able to import that. Let me first find out whether that is the right version. Just wait for a second.
So we've prepared a project where you should actually work in. I forgot to give you the project.
I think no, this is perfect. Okay, so
okay,
yeah, I'm going to share this with you. Wait, why can't I share a file? Why can't I drag it in here? Does it
work?
Oh, it does work. Okay, good.
Great. Okay, so this is the blocks library for the gesture recognition. So you can now all download this from the chat. And don't double click it because it's an XML file, not an executable file. You can just drag it into Snap to open the blocks. So you can see that I now
into the project you're working on.
Into the project that you're working in, right? So this, if you have a blocks library, which you can, by the way, create yourselves from custom blocks that you've made. This will just be added to your project and to the blocks that you already have. So in this case, for example, I got this render block in the pen category to my project, and I also got the animate block and resample blocks that we now want to use. So I'll go to the looks category and drag over the animate block. I will open it real quick and show you what it does. So the animate block is a C-shaped block that lets you use the drawings that you've made. So with this pen trails block, so the pen trails block, let me show it real quick, reports an image of what's drawn on the stage, and you can use that pen trails block as a costume here, and then your sprite switches to that costume, and then you can execute whatever action you want that you can input here in that C-shaped input slot, and then the sprite, as I said, looks like the pen trails that you've drawn. Okay, so for example, in this animate block, if I've drawn a heart, I want the heart to beat twice. Beating twice could mean that we want to hide it or show it and wait in between, or we could make it a little smaller and a little larger. That depends on you. So let's just, I would just show it and hide it. Oh, that's more like a blinking thing. No, let's grow it and let's make it small again. So for example, we wanted to repeat 10 times, increase the size. So I'll change the size by, let's say 5 each time. And then I want to set the size back to 100. And this is how this would look. And maybe I want to do that twice because hearts beat twice. So let's just wrap another repeat around this. And we want to repeat this twice. So whenever I execute that script now, my heart will beat twice. And also let's just add a message here at the top, because later on when we recognize a sketch, we will just broadcast the name of that sketch or the description of that sketch. And our scripts then can react to this description. So let's add a when I receive block right away. And let's add a new message. And this is what's supposed to happen whenever we draw a heart. So when our script receives heart, it's supposed to do that. So let me try to draw a heart. And let's do it. Okay, now if I draw something else, for example, a star, I might want a different animation because stars don't beat. So maybe we want the star to, for example, turn around, or we could make it blink. So what I just said, we could make it hide and then show again twice. So for example, when we receive star later, we want our sketch to blink twice. So let's do it 3 times. Blink 3 times, and blinking in this case, as I said, means showing and hiding the sprite. And that we see something, we need to wait in between. So let's wait 0.2 seconds, for example, here, and 0.2 seconds there. So when I draw a star now, it can blink 3 times. Okay, in the next 2 to 3 minutes, maybe you can all come up with 2 or 3 more examples on what can happen whenever you draw something. And then we come to the gesture recognition part. And let me just check the chat.
I think I took care of the chat.
Okay, great. Thanks. Okay, what else could I do?
So kind of accidentally, what we did right now is something you might want to do too. We, when you're teaching or interacting with a class, sometimes it's great to share a project stub where it kind of has an incomplete program that you let others complete. Or sometimes we just share some blocks and let students kind of arrange them to do the task that we prepared. And that depends on how much time we have. Like we have a version of this activity where we build everything from nothing, but that's a longer activity. And that wasn't what we were going to show in this workshop. This workshop, we want to focus more on kind of the big picture. And this is why we prepared the library. So you can either prepare a project stub, or as we did right now, share certain blocks of your project. And those can be imported later on as you've already started a project. That's the benefit of that. So nobody has to do their work over again. So the reason why Jadga is starting on the stage is that we need to capture the event when the mouse is down. Now, if we can't capture it on the sprite because we're not showing it the sprite, so it isn't registering any when I am pressed event or when I'm entered by the key. This is why we can need the stage as the sensor, kind of like a touchpad or like an iPad, like the whole screen notices when something happens. And this is the one part why we start on the stage, because you could click anywhere on it, not just where the pencil sprite is.
Okay, so if you need more time, let me know. But I would now come to the next point, which is the first one that we need to actually recognize our sketches. We can't really compare the images, but what we compare is rather the paths that our sprite moves. So we need to record that path somehow, and we can do that by adding the corresponding X and Y coordinates each time we move and each time they are recorded to a list. So let's create a variable first with the make a variable button in the variables category, and let's call that variable sketch. The sketch variable is supposed to be a list, so we'll set it to an empty list. It's also now shown on the stage here. And now, whenever we went to the mouse pointer, we want to add the current X and Y position, so the current location of our sprite, to the sketch. We can do that with the add block, and we can create a position by just adding a list of X and Y position of the sprite to the sketch. Okay, so we want to set the sketch to an empty list every time we draw a new sketch. And then, as I said, we want to record the current position every time after we've moved the mouse to the sprite to the mouse pointer. Okay, let's try that. Let's draw a heart again. Okay, and you can see that I now get a lot of points. In my sketch list here, or it's basically a table from X and Y positions of the sprite. Wow, I was better at drawing hearts before. Okay. As you can see, whenever I draw a sprite or a sketch, it depends on, or its size is different every time. So it depends on how fast I draw or how much time I need to draw it, or how big it is. So we need a way to compare different sketches. To do that, we have a resample block, and we can resample a drawing to a specific number of points. So let's make another one. I make this heart. It contains 230, the list contains 230 elements, and now I can now resample that sketch, for example, to 64 points. What the resample block does is we can see in the render block what the resample block does. So I can resample my sketch to a specific number of points. Let's do 230. This was the actual length of the sketch, and what you see is that I just get the drawing back as I had it before. But let's now try half the number of points. Or just 30 maybe. Do I need to clear that before? Let's try it again.
Maybe.
Okay, so this is my drawing. And now let's render it to 30 points. So what you can see now is that you get 30 evenly distributed points along the drawing. Let's try it with a different number. So now it's only 20. Let me add the clear block at the beginning here. We can also just try 3. Then we get something like a triangle, or we can try 40. And you can just play around a little bit with the different number of points. And also you need a different number of points to still see the actual shape. So for example, for a heart, something like 10-ish should be enough to still somehow see the shape. For a more complicated shape like the boat, for example, you would need way more points. But we found out that 64 kind of works for all shapes that we've tried. So this is a pretty good solution. And you can also animate that with the for loop, just as a little side fact. So for example, for I from 1 to, let's say, 100, you could also always resample your sketch and render it again with I points. So let's try that. And there you can see, you can basically recognize the heart pretty early. Let's try something different, maybe the boat again. How did I do the boat? Like this. So for the boat, you need way more points to actually being able to see it, but 100 definitely is enough to recognize the shape for us. So as I said, what we need to do to compare those sketches is we need to resample them to the same number of points, because what we're going to do in the recognize part of the script that Jens is showing you in a minute is actually comparing distances of points in different shapes. And we need to take care that we normalize all our sketches before we compare them, because if you compare a sketch with, I don't know, 300 points with a sketch that only has 10, you will get a big difference, even if it's the same drawing that you retrieved those points from. So it's really important that we normalize all our drawings, and this is what the resample block is for. And now the last thing that I wanted to do with you before I hand over to Jens is that we actually need to create a examples base. So we need to add some examples that we can compare our sketch to when we get to the recognizing and comparing part. So for that, we need a second variable, which we call examples. So I make another variable and I call it examples. And also examples is going to be a list. So we are initializing it as an empty list. So here's our examples. Oh, here's our examples variable. We can now draw something and add it to the examples. And what we want to add is a combination of the resampled sketch and the name of that drawing. So let's build the structure of what we want to add first. So we want to add a list that contains the name of a drawing. So let's do heart first again. And then also the normalized or resampled version of the sketch. So we need the resample block again and the sketch. And as I said, it works pretty well with 64 points. So let's just keep it with the, or leave it with the default value. And then we also need to specify to where we want to add all that stuff, and we want to add it to our examples list. So let me draw something, a heart. And then let's add that heart to our examples list. So here now you see that, that I have a list that contains a list, which is a The first one is the sketch. Every one of these elements is the position, X and Y position, so another list. And here we have the name. We can also show that as, we can also show that as a table. So here we can see it. This one is the sketch and this one is the name of the sketch. So here I have all the positions and here I have the name of my example, which is a heart. Okay, let's try another one.
Let me just come in here. That we're getting the wrong kind of formatting just happens because we initialized the list first before we added another one to it.
Yeah.
So we can kind of force it to relay out after we kind of turned it into a table by deleting the watcher and showing it again. Deleting the watcher is you just drag it off into the into the palette and then you show it again. And then we should be seeing it correctly. This we honestly don't know how to format a list, right? Sometimes we find out later that its format, that its dimensions have changed. So this sometimes happens when we do it progressively.
Okay, so then let's just add your other examples that you created animations for to the list. So this is my example for a star. And I can also add some other examples for things I might want to do later. So I don't know, let's add a droplet. And let's add a tulip. Oh, wow. And maybe let's add the boat again. Okay, so here I now have a list with 5 examples. I have 1 heart, 1 star, 1 droplet, 1 tulip, and 1 boat. And I have 5 corresponding sketches. So let me draw now. Okay, let's just hand over to Jens, and he will now show you to how to recognize those sketches and compare them with the one that you've currently drawn. Is that okay with you, Jens?
Maybe not, because I wasn't building along. But
I can just share my project.
You could share your project. Yeah, that's great. Why don't you share your project?
Yeah, wait. So I'll call it snap conjectures. Let me also share the project. Okay, in case someone else wasn't able to follow along or didn't follow along,
open the same thing.
You can also use that project that now contains my sketches. Okay, so I'll stop sharing and Jens can now show you how to recognize all the patterns that I've drawn, or maybe he needs to draw his own ones because mine might not work.
I'll try to use yours. Okay, let me share my screen. This is going to be really quick because Jadga has done all the work and we've put all the rest of the work into the library that we've shared. So my job is really just to use a single block for this. And that is the recognize block that's already in there. It says recognize a list in a list, and what it means, kind of, we open this, we can kind of find a hint. It recognizes a drawing. That is one of the sketches that we've done in the list of examples. And, you know, never mind how this works. Basically, it tries to find the one where the points are closest to each other. So it circles through every point of the drawing that we've made. Once we've normalized it, kind of resampled it to 64 points, and compares it with every example that we've drawn. And what it does, it basically, for each point, it checks the distance between each point of the sketch that we've made with each point of the example it is looking at. And then it just adds them up. And the one that has the least accumulated distance is the one that it is most likely to resemble. This is basically all the magic there is to it. It's a little somewhat complicated block, but it's all written in Snap. So there is also a version of this activity where we kind of do this ourselves. But for our purposes here, we just gave this to you. You can just also give this to your students. We can just use this. So let me actually try to do this. So I'm trying to draw a heart like Jadga drew a heart. Was it like this, Jadga? Was that right? No.
I think I start at the bottom and then move to the right and then to the center and then to the left.
Something like this?
Yeah.
Okay, let me try
Just
this again.
more beautiful.
It's really hard. Yeah, okay, good. Yeah, right. So, okay. So here's my sketch, right? This is the sketch, bunch of points. And so basically how to use the recognize function is, well, you put the sketch that you've recorded into the first slot and the examples into the other slot. Wow, and now we'll see whether it actually works. Oh, Jesus, it doesn't. Okay, oh, it's supposed to work. Why isn't it working? By the way, why is my screen too? How can I get this? Go away. Okay. Wait, that's totally how it should work. Let me see. Wait. The examples is a list of lists. Yeah, looks right. 64. This looks also right. Okay, let me see what's wrong here. It says it's expecting a list but getting a text. That's interesting. Oh, okay. I think I get it. It's supposed to get the item 2 and the item 1. We changed it, I think, right? Is that the thing? I think that could be it. Yep. Okay, good. Okay, so I'm sorry for that. That was kind of a last minute change. In previous versions, we made it that we kind of made the example so the word, kind of the tag, was kind of in the left column, and the shape, the path, was in the right column. Then as we were kind of developing this activity, we thought, well, it's the other way around. We really want to have, and Jadga is going to show you that in a minute, we really want to have the shape as the key and the tag as the value. So, okay, in order to get this, I'm sorry, you can't just use the recognize block. It's not as quick. You need to edit it and change the number here to item 1 and the number here to item 2. We were relying on a different data structure. Okay, I'm just going to leave this open. So these 2 item of blocks in the definition of recognize, sorry for that. You need to switch, you swap these, but then it should totally work.
I can also just change it in my project, then you can at least use that. So
right, yeah. Why don't you just change it in your project?
Where did you?
Wait. You know what? I'm just going to export the blocks again, and I'm going to share the library again, and you could just import the library into. Oh wow! Look at that. So now I changed it here, so I can export the block. Actually, I'm just going to export this one block. This is another new feature in Snap 6. So we can export this one block, this one recognize block, by right-clicking on it in the palette, and we say export block definition. And what it will do, it will export not just this one block, but all the other blocks that this one block relies on. So, so this is what we can do. I'm actually going to export the whole library again, export all the blocks. So here it is. Down here, so I'm going into where is it? Downloads, SnapCon gestures blocks, and I'm going to share this now. Wait, for this I need to go to the chat. Did I mention I need to get a bigger screen? Where is the
Not
chat,
yet today, but
I didn't mention
you
that
have been mentioning
okay,
that.
Oh, here's the chat. Okay, look at that. There's the chat. Okay. You can't see the chat, right? Or you can't see the chat? Okay. So why don't you all just download this thing from the chat and just drag that into your project. It'll overwrite the other block with a new version, and then it should just totally work. This is another way how you can synchronize when working with groups. Yeah, I mean, come on.
Cool. Totally works.
Totally works. Okay. So now you can just use the recognize block. And so the fun thing about this is, you know, we're basically done, right? So now we can enter something that we've drawn, anything, because you know, it resamples it in between. So now that was the question in the chat. How do we never broadcast these things? Well, what about we broadcast them now? And this is actually kind of cool. So now we take out the broadcast block and we broadcast whatever we're recognizing. Since we're putting this here in the sketch, and now what we're doing is, after we've written something, we analyze it and we immediately broadcast it. So let me try this hard again and see whether now actually this thing should get triggered, right? So I'm drawing the heart in a Jadga way. Yeah, look at that. Let's recognize it. Okay, how did Jadga draw her star? Probably not like this. Did she draw it like this? No, right? He didn't draw it like that.
There was a question in the chat, and maybe this is the right time to discuss it. Does this also work when you draw things the other way around or at a different position? And the answer is no, it doesn't, because especially the other way around doesn't work, because we're recognizing paths and then comparing each point. So if I draw them in a different way, it will have a maximum distance, even if the drawing is exactly the same. The thing is, we found this out on the way while developing that project, because I wasn't able to use any of Jens's things. And we later found out that this is because Jens is right-handed and I'm left-handed, and left-handed people draw everything differently and then it just doesn't recognize it. And this is also a pretty cool example to just talk about bias, because I was just not able to use Jens's project, and I had to add my own examples where I start the drawings from the other side or to the other side, so I was able to use the project.
And so this is actually the really great, we're really something where this activity now is leading up to as we're doing this with students. So now we're basically done with the technology. So we have everything that, you know, an AI machine learning program does. We have something, we have some algorithm that does some magic. It actually learns by the more data we put into it, the more it learns. But we also have the problems, like the bias problems. You know, it's discriminating against me because I'm taking Jadga's left-handed project, and the other way around. And so I think I'm now going to hand over again to Jadga, right? So to kind of show how we can address these things. So
I didn't really prepare anything of that.
Good. So then let me do it. Okay. So it didn't recognize my star, even though Jadga has a star in here, right? So it, let me find out how she drew it.
I start everything from the bottom right corner and move to the top left, I think.
So maybe like this.
No.
What does it recognize, by the way? Oh, a tulip. I recognize it. That's not a tulip. That's a star. Oh wait. Okay.
How can it be that my program, which is the same as yours, is recognizing stars independently of whether I start from one side or the other?
Because you only have one shape.
No, I have 4 of them. Does it default to one if it doesn't?
No, it doesn't default to one. So actually, it's kind of amazing. The other question was like, does it recognize it when you draw it kind of down here or up there? And it's actually pretty good in finding similarities because these paths are kind of have this sense of direction because you start them somewhere. It's actually, it's pretty great. It's just when you start the other way. So now look at this. So now I drew a star, but it probably thinks it's a tulip because that's how Jadga draws a tulip. So how do we deal with this? And really the solution is oh wait, no, that was wrong. That wasn't supposed to be the boat. Let me actually delete that again. I didn't. Oh, I can't. Oh, yes, I can. Delete it. Thank you. Okay. Wait. So we should be able to add more examples. You know, one example just isn't enough. So this is another example of star. So look what happens. Now I'm adding another example of a star here. So I have two shapes that, you know, I can draw them either way. So now if I draw a star, again, the same way as I drew it now, it recognizes it. And did you notice I didn't draw it like the example. I made it smaller and somewhere more in the corner. Well, let's actually try this again. Let's draw this here. And it also recognizes it. It's actually pretty great, even if I tilted a little bit. I'm just claiming these things. Yeah, it's actually working. So the trick really is, and you know, let's draw the heart the way I draw a heart. And can I stop this stupid stuff from coming in? So it didn't recognize it. Did it recognize this heart? No. Oh wait, it didn't recognize that one. So I'm also going to add this as another example for heart. So the more examples we give this program, the better the chances are that it recognizes something which is going to be drawn in a different way. And that's really something when we think about it, which is great. Like there isn't just this one example also for us that everybody learns by. It's what we in Germany call the Schulbeispiel, kind of the school example. More examples help, especially for a diverse audience. Ooh, we're getting kind of, okay. So that's kind of a big idea behind this algorithm. And behind most of these machine learning algorithms, give them more data, they will increase the quality.
And this is also a pretty neat example of supervised learning because you learn with labeled data, you're creating the labels yourself, and it already works with like 2 or 3 examples pretty well, which is not true, for example, for image recognition or something more complicated. So that's why it's a pretty neat example also for schools, because you can create the data that you train the algorithm with or the program with yourself. So that's kind of nice.
And now what we have really is this basic framework. And this is just like we can train it and we can play it in the same, with the same just little project. Now, of course, the fun starts. Now we can add more animations for the other things that it knows. We can use it to think about stories and use symbols to tell little stories. And that's kind of where it gets creative. So what we're trying to show in this activity and why we love it so much, there are many aspects to this. We can actually build all these blocks from nothing. Then it's all about math. How are we going to determine the distance between points? How are we going to accumulate the distance between 2 paths? How are we going to find out which path has the least distance to any other given path? Those are kind of the math stuff. That's also fun, but it's also just fun to just use these blocks and think about the bigger picture, which is, oh, why doesn't it recognize the star that I drew because Jadga made the example? And what does this tell us about maybe communication among ourselves, like when we're not understanding each other? Maybe we just need more examples. And this is a real fun starting point for other projects where kids can animate their stories or control their games using drawing arrows or stuff like that.
So Jens, a quick question. Is it possible to do this programmatically so it's independent of the individual's activities? Because I mean, no matter what you do, another person might draw something totally different in a sequence wise. Or is it just a matter of left to right versus right to left direction in the points? I don't know.
Do you think that can I have one example and have a program determine any way? Sure. I mean, I guess you could also always add the reverse, right? I mean, that's the simplest way. Is that, Turgut, what you were thinking of?
Well, I'm trying to understand, is the issue of starting point and the progression direction up, down, or left, right? Or is it more like a mirror image of something? Or is it a coordinate sequencing from one to the other? Or is it more like it does, once the image is drawn, it's a heart, but it's not a heart because you didn't draw it in the same sequence, let's say. So I'm trying,
Exactly. So
once
now
you
it
draw,
finds out this heart, right?
yeah.
No, it doesn't find out this heart. Oh, it doesn't find out this heart. Let's actually add this also to the heart. So now it finds out this heart. Yeah. But and it finds out this one. So we could, oh, it doesn't find out this one. So let's add another example. So now it finds out this one. And the more examples I give it, so, and so one thing, of course, would be you could think about formalisms. Like you could say, I also just want to add, the reverse of a path, right? But maybe that's a little too easy because some people might, draw it even the other way. Like I could even draw it like this. It's also hard. It didn't recognize it, right? So let me add that again. So now it's recognizing this. So I really think the beauty of this program is that it's, hand sketching. So it's obvious that it's something individual. It's something that, I do and is different from what you do. And so the way these AI programs learn is you give them a lot of data, so you kind of get a representative sample of, how everybody might draw these things, and you get different examples, and then that increases the chance of recognizing something. I don't think this is a good example for how you can use math to find every possible way how you can draw a heart, because really whether it's a heart is something that you decide as a person, right? There might be other cultures that have different signs that mean something totally different, right? And so you're going to tag them differently. So I think it's as much a cultural play as it is about the algorithm.
I think the issue here we have with the not recognizing is the fact that we're dealing with a path as an entity rather than an image, which is a bitmap. Because in normal AI programs, from what I've seen in the algorithms, they would take the screen and then they would split it up in, like we do, 64 data points, and we look at the sequencing and distance between them. That's actually the recognition algorithm. But in an image algorithm, they would take the entire screen, split it into some kind of like 8x8 matrix of whatever, and then analyze each content, and then look at the relationships in between to come up with whatever it is. And
Yep.
then when you do it that way, then you're independent of the drawing activity. But this one is very specific to path. And so we have a path direction and all that.
That's very true. But that's also kind of what's fun about it, because you can use gestures for other things than to represent a static image. You can use gestures to represent something, actually motion, right? And so if you look at other gesture recognizer algorithms, or at even the algorithm that we derived this one from, the $1 gesture recognizer from University of Washington, it has more components to further normalize the drawing. So what we've now done is we've basically looked for the least kind of what's the tiniest thing we can do that already lets us do something like this. And that's the resample function. Now, even if you use kind of the way that this is published in the paper, they have more steps in there. Like they also, they start with resampling, then they also scale it to a normed box of a side length. They find out an intrinsic direction by taking the first point and the centroid point, and then they rotate everything so everything kind of aligns. So it doesn't matter whether I'm drawing the heart like this, which it does, now it thinks it's a star, right? And this is it's a mathematical issue, right? You can find out that this is actually very similar to this. And so the actual $1 gesture recognizer algorithm has more of these components in there that further abstract it away, so that it's that with just fewer examples you can recognize a wider range of what people consider to be the same gesture. And it was actually interesting when we tried the actual full $1 gesture recognizer. Brian Harvey complained, "Oh wait, no, that's not what I meant. It's turning. It should discriminate more. It shouldn't just draw it because I want to draw it the other way around, and that shouldn't be a different gesture." So all these things lead to very interesting discussions about why is it different for me but not for you. So there we had the different case. Like Brian wanted it to be different, whereas the algorithm said, "No, look, this is going to be the same thing."
Okay, I just got noticed that we're already at the end of the workshop. Great that you were all here. If you have questions, feel free to ask them during the conference. Jens and I are around, and hopefully see you all in the keynote.